Hello, this is my video for Newton's third law. At the start of this sheet are just a small summary of what we did last time. You should easily be able to answer both of those questions now. Okay, here it is, Newton's third. Whenever two objects apply a force on each other, in this case, the box is pushing down on the table and the table is pushing upwards on the box. And these two force vectors are exactly equal and exactly opposite, and they always will be. So whenever something pushes something else, the something else pushes it in exactly the same way. Now, you've seen the demonstration with the strain gauges at this point, but I'd like to propose a little test. If we accept that Newton's third law is true, and we know, therefore, that there's an upwards force on the box, why doesn't it go flying up into the sky? Because Newton's second law tells us that the box should accelerate upwards by F equals ma. And we can all see there's books on our tables, computers on our tables, and yet they don't jump. Now, if I was doing this in a real class, I'd make the students work really hard to get the information from that. It does look like a paradox, and it's not really a paradox because there's another downwards force on the box. The force of gravity is attracting the box downwards. So this is just incomplete. This is only telling us the interaction between the box and the table, but there is another force downwards on the box provided by gravity. And likewise, the table doesn't sink into the floor because it's pushed upwards by the floor as well. So here's my statement of Newton's third law. If object A exerts a force on object B will exert an equal and opposite force on object A every single time. And on the student's A-level exam, there's no exception to that. But of course, if the class is reasonably ambitious with physics, I can tell them how they can actually escape Newton's third law. There are certain situations where it doesn't follow. This NASA video is somewhat good, and I would recommend the students watch this at home as well as in the classroom. Okay, here's the big thing for my plan today, is draw a diagram much the same as that one, only for a planet-moon system. So here goes. Open GeoGebra. Planets are circular, so I'm going to do it like this. I want to change that name to planet. And then I want to add another circle, say here, with a smaller radius because this is the moon. And I'm going to change its name to moon. Okay. So now all that is required is for us to put on some force vectors, and the vectors are in here with the lines. I'm not too concerned about the lengths of these. We're not making any calculations to the mass of the planets or the force of gravity. Just want to get the students making something. See that point there? Turn it off, right. So this is the force of gravitational attraction from the moon on the planet. So now we need an equal and opposite vector to represent the gravitational attraction of the planet on the moon. But it's got to be equal and opposite, and this is a trick. So go here and go to, actually I'm going to put on another vector here, vector from a point. So choose that point there and then choose the vector. So all it's done is copied that vector to the new position. As you can see, it's pointing the wrong way. So this is a little trick. It's not much of a big deal. Reflect the object in the point, choose the object, and then choose the point. Now we get the force vector in the right direction. And then we can clean it up a little bit by taking off the V and the W. In fact, I think I'll do that. I wasn't planning on that, but I can. Can't remember. Oh yeah, there it is. So here it's force box on table. So you can is force planet on moon in latex. I'm assuming in my my planning here that the students are all competent with this already, because I've had students at my current school about 14 years old and during quarantine, not Button, sorry. And during quarantine, we've had no choice but to get very, very good at doing stuff on the computer. There it is. So we just got to move that. So the planet on the moon is going on that one. And then we can turn off the label. So we just have to do that again on that vector there. And hopefully the students will be very proud of their creation. And it only took them about 5 minutes. We got a bit of practice with LaTeX, which is mathematical language. And I provided them with some revision materials, which they can probably get out of their bags with pride a year and a half from now when they're taking their exam, and they'll remember it precisely. That's really all I've got to do. Let me introduce the plan just a little bit. That's not the plan document. There's the starter, which was the first and second laws. Then there's the demonstration with the strain gauges, which I linked the video to explain what that would look like. Then there's this brilliant NASA video about on the ISS proving Newton's third law. And then I left that little trick, that little ambiguity into my table box diagram just so that it can stick in their heads as much as possible. And yeah, we did everything we wanted to do. Thank you.